Today we are going to discuss about B-tree deletion operation. This is the pseudocode for deletion, deleting a key from a B-tree. So suppose here there is a node denoted by X. Here this is the node X and we need to delete a key from X. That is, here this is a node X and which containing a key K, and we need to delete this key from this node. So if X is a leaf node, we can directly delete K from this X node. So that is the first condition. The second condition is if X is not a leaf node, it is an internal node. That means it is not a leaf node, then it containing some children are there and it has some parents. So it is a internal node. Then we are checking the other three conditions. If the child Y that precedes X in the node K in the node X has at least T keys. So here this is node Y, and here if Y has at least T keys, then find the predecessor of K. That is, predecessor of K is K dash. Then this is the K dash is in the subtree rooted at Y, and recursively we delete this K dash and replace this K by K dash. That is, we are delete this K dash from the subtree and we replace this K with K dash. So here replacing here. The next case, that is the first case. If Y has at least T keys, then only we can replace it. Then if second case, if Y has fewer than T keys, if it has lesser than this T keys, then symmetrically examine the child of that node. Suppose if this has less than T keys, then we are checking that examine the child set that follows the K in the node X. So here the children of uh, K, that is Z, this is the Z node, and we find the successor of the K, that is K dash. K dash is the successor of K in the subtree rooted this at Z, and we are delete this K dash from here and replace this K with K dash. So we need to delete this K. So either we find a predecessor of this K and replace it, either otherwise we are find the successor of this child this K and replace with it. Suppose if both this Y and Z have only T minus 1 keys, that is less than T keys, that is, then we merge this K and all of Z into Y. So we merge here X, Y here in, like this, K and Z, merge all these elements so that X loses both K and the pointer to Z and Y. Now it has 2 T n minus 1. Then free the Z and Y and recursively delete K from this y. So here what will we do? ഇപ്പം നമുക്ക് ഇവിടെ നോക്കുമ്പോൾ ഇവിടെ t-1 എലമെൻറ്റേ ഉള്ളൂ, ഇവിടെയും t-1 എലമെൻറ്റേ ഉള്ളൂ. അപ്പോൾ ഇതിൽ നിന്ന് രണ്ടിൽ നിന്ന് നമുക്ക് ഡിലീറ്റ് ചെയ്യാൻ കഴിയില്ല. കാരണം നമുക്ക് അറ്റ്ലീസ്റ്റ് t-1 എലമെൻറ്റ്സേ ഒരു നോഡിൽ ഉണ്ടാവുകയുള്ളൂ. അപ്പോൾ അത് കണ്ടീഷനാണ്, t-1 എലമെൻ്റ് എങ്കിലും ഒരു നോഡിൽ പ്രസൻ്റ് ആയിരിക്കണം എന്നുള്ളത്. അപ്പം നമുക്ക് ഇതിൽ നിന്നും സക്സസറിനെയും പ്രെഡിസസറിനെയും ഫൈൻഡ് ചെയ്യാൻ പറ്റില്ല. അപ്പം നമ്മൾ എന്ത് ചെയ്യും? ഈ കെയിനെയും കൂടി ഇൻക്ലൂഡ് ചെയ്ത് മെർജ് ചെയ്യും. ദെൻ നമ്മൾ കെയിനെ ഡിലീറ്റ് ചെയ്യും. കെയിനെ ഡിലീറ്റ് ചെയ്യുമ്പം ഇവിടെ എന്താവും? കെയിനെ ഡിലീറ്റ് ചെയ്യുമ്പോൾ ഈ രണ്ടും കൂടി മെർജ് ചെയ്യുമ്പോൾ ഒറ്റ സിംഗിൾ നോഡാവും. സിംഗിൾ നോഡാകുമ്പോൾ അതിനൊരു സിംഗിൾ, ഇതിനെ കെയിനെ റിമൂവ് ചെയ്തിട്ട് ഇവിടെ നമ്മൾ മെർജ് ചെയ്തു. ദെൻ ഈ കെയിനെ റിമൂവ് ചെയ്തു, കെയിനെ ഇതിൽ നിന്ന് റിമൂവ് ചെയ്തു, കെയിനെ ഇങ്ങോട്ട് കൊണ്ടുവന്നിട്ടാണ് റിമൂവ് ചെയ്യുന്നത്. ദെൻ നമ്മൾ ഇവിടെ നിന്ന് ഈ രണ്ട് പോയിൻ്റർ എന്നുള്ള ഇവിടുന്ന് കെ പോയി കഴിഞ്ഞാൽ ഒരു സിംഗിൾ പോയിൻ്ററേ വരുള്ളൂ, അത് ഈ മെർജ്ഡ് നോഡിലേക്ക് പോയിന്റ് ചെയ്യും. ദറ്റ് ഈസ് ദി സെക്കൻഡ് സി കണ്ടീഷൻ. ദെൻ തേർഡ് കേസ്, ഇഫ് കേസ് ദിസ് ഈസ് എ node x but k is not present in this internal node, then we determine the child where the k is presented. The child node, then k containing in some child node k. Then here it has only t minus if x, this is x, xci means here it is the ci child node and it has only t minus 1 keys. Then we perform the step 3a or 3b, that we descend to a node containing at least t keys, then finish by recursing on the appropriate child of x. So first case, if xci, this is x dot ci, has only t minus 1 keys, but it has an immediate sibling with at least t's. So its sibling is here, this is the sibling of this node, and here it has t keys. So then what will we do? Give this xci an extra key by moving a key from x down into xci and moving a key from xci to immediate left or right sibling up into x, and moving the appropriate child pointer from the sibling into xci. Here we need to remove this k, so it has only t minus 1 key, so we will check the sibling of this node. So this is the sibling of this node and it has t keys, so we are taking from 1 key from this key and we remove this key and we move 1 key from this x node into this xci. So here it has t minus 1 key and we take 1 key from this sibling and it moved to the x. So here now t minus 1 keys only. So it satisfies the cases or properties of B tree. This is the case 3a. The next case 3b. In the 3b, here both this is x, here this x node has two children, xci and xci, and these two siblings has t minus, having only t minus 1 elements, so we can't take an element from any one sibling and we can't replace with it x. So what will we do? Here we are take this element from this x and it moved downwards and it considered as a median and merge these two siblings, and this node is pointed to here. So like this is the third case. Then for an example, here this is a deletion of, here minimum degree is t is equal to 3. So at least each t has a t minus 1 elements, that is 2, 3 minus 1, that is 2 elements must present in each node. So first, this is the initial tree. So we need to delete f. So f is containing in the leaf node. So we can directly, it is the case 1. So we can directly delete f from the tree. So we directly remove f from this tree. So next we need to remove m. Delete m. Here when delete m, here m is not a leaf node, it is an internal node. So what will we do? First we check the predecessor. So here predecessor child has t elements. So t elements means t is equal to 3. So 3 elements are here. So we find the predecessor. Predecessor is L. So we replace this L with M. So that is here. We are removing M from this internal node and replace L with that. That is the 2 case. The predecessor L of M move up to take M's position. So next we need to delete G. So G is here. So G is an internal containing the internal node, and we are checking is predecessor and successor child node. So both are t minus 1 elements only, that is 2 elements only. So we can't take an element from its successor or predecessor. So what will we do? We are merging these two nodes and remove this G and point it to here. So we are removing G and merge this node. So D, E, J, K. So G is removed from this and point it here. And this is the case 2C. We push G down to make the node D, E, G, J, K, and then delete G from the leaf node. The next case, delete D. So next case we want to delete D. So when we need to delete D, we are checking this root node. Here it is also t minus 1 keys are there, and here is sibling also t minus 1 keys. So what will we do? We merge these, we are moving down this root P to downwards and merge this as a single node. So it is CLPTX. Then we remove D from here. So that is deletion of D. This is the case 3B. So the recursion cannot descend to node CL because it has only 2 keys. So we push P downwards and merge this CL and PTX, then delete the D from this leaf node. So now its tree size is shrinks. It shrink this tree height. Then we delete. Here there is a root node is there. We directly delete that root node because it doesn't containing any elements. So its height will be decremented by 1. The next step we want to delete B. Last condition we need to delete B from here. So it is a case 3A. So 3A state that it checks its sibling. Here sibling is the T keys are there. So we remove this B and take an element from here. C is moved to B, and here we are siblings, one of the siblings, that is key from the sibling, that is E is replaced here. So it has only T keys, so we can replace with it. So E is replaced here and B is removed and C is take place its position. So C is moved to fill B's position and E is moved to fill the C's position. So this is all about the B tree deletion. That's all.